Okay, guys. Yesterday,
Hello.
today we are going to discuss about AWS. So basically, there are two types of data centers. Types of data centers. One is physical data center. We also call on-premises data center. On-premises data center. The second one is cloud data center. Yesterday, I have shown the pictures. What is data center? How it looks? What data center contains? So data center contains servers, storages, switches, and routers. All this infrastructure will be maintained by the cloud, either physical data center or a cloud data center. So what exactly data center? Data center is a physical location. Where the servers, storages, switches, routers, are hosted. All these are hosted one place. That place we call as a data center. Drawbacks. Drawbacks of physical data center. Drawbacks of physical data center. Let us say, for example, you want to host an application. What is required? I need a server. This is the server which contains. This is the server contains hardware. On top of the hardware, they are going to install the operating system, either Windows or Linux. On top of that, they are going to install the application, Java or Tomcat. On top of that, a database. This is called as a server. A server contains operating system. A server contains Java or .NET, any programming language. A server contains a Tomcat, which is application server, a database. Database we never keep in the physical server. Tomcat, and this is the API, application program interface, user interface. And people are accessing my application from internet. The people are accessing my application from internet, either from laptop or desktop. What happens if I have only one server, only one physical server, and install everything on the one physical server? When more number of users are accessing my application, that increase network traffic. There might be chances of my application is down. When my application goes down because of huge network traffic, when my application goes down because of huge network traffic, then immediately the people they migrate to the another application. For example, you have Uber app, Uber or food apps, Swiggy, Zomato. When I'm trying to order the food from Swiggy, it is taking more time. The app is not opening. The app is not opening because of huge network traffic. I have only one physical server. Because of one physical server, huge network traffic, the Swiggy app is not opening. Immediately, the customer switch to the Zomato. So I'm losing my business. I'm losing my business. So what we are going to do is, in real time, we are going to keep a backup server. The same hardware, same compute capacity. What is the meaning of compute capacity? What is the meaning of compute capacity? Same RAM, same processor. Same RAM, same number of processors. The meaning of compute capacity. The meaning of compute capacity, RAM and processor. Your application or your database, the performance based on the memory and processor. Based on the memory and processor. So the compute capacity means what? How much RAM, how many processor. Assume that this server compute capacity is 128 GB RAM, 128 GB RAM, and this processor is 16 processor. This is my compute capacity. While taking the backup server, the backup server should have same compute capacity, same hardware, same hardware. So we'll take another server, same hardware, install operating system, Java, Tomcat, and so on. And here, on both the servers, they're going to configure one load balancer. This is called load balancer. What is the meaning of load balancer? The load balancer distributes the load or distribute the traffic. The load balancer job is distribute the load or distribute the traffic. In the real time, all this web application, we discussed what is web application. All this web application, they're going to set up more than one server. All these applications are running more than one server. Minimum 2 servers. Minimum requirement is 2 servers. And both the servers are configured with load balancer. Both the servers are configured with load balancer. Both the servers are configured with load balancer. If any request coming from the customer, from the client, assume that this is my client. When the client request, when the client is accessing the application, when my customer accesses my application, the request sent to the load balancer. The load balancer distributes the load. If this server is busy, the traffic sent to the another server. Or if this server is busy, traffic is sent to the another server. The real time, here just example, 2 physical servers. In the real time, you might be having more than 2. You might be having more than 2. I'll give an example. Go to command prompt, Windows command prompt. Type ns lookup and set type is equal to ns stands name server, type yahoo.com, ns1, ns2, ns3, ns4, ns5. There are 5 servers. Here I mentioned only 2 servers, but yahoo.com maintaining 5 servers. When you type yahoo.com or www.yahoo.com, the request sent to ns1. If ns1 is busy, when ns1 is busy, the traffic sent to ns2. If this is busy, the traffic set is 3. This is called load balance. The real time, the application will always runs on multiple servers. So in AWS, we have a concept called load balancer. In first class, we discussed what are the types of load balancer in AWS: network load balancer, NLB, network load balancer, ALB, application load balancer, network load balancer, application load balancer. We have a separate topic on that. We'll discuss that theoretically, practically. So this is called a simple example for how this application works. What is this physical server? What is this infrastructure? But no application in the real time without database. No application real time without a database. So they take one storage. This is the storage. What is storage? A storage is a physical device. A storage is a physical device which contains more than one hard disk. A storage is one physical device which contains number of hard disks. All these are hard disks. It contains number of hard disks. In this storage box, in this storage, we are going to install the database. The database may be MySQL database, MS SQL database, Oracle database, any database. Why do you need a database? You are doing some transaction, deposit amount, drawing amount, where that report will be, where that data will be stored in the database server. You go to bank and you ask for the, go to bank, you ask the 6 months bank statement. If you have 3 months, 6 months bank statement, where the database, where the data is in the database server, how they're going to generate the statement? Because it's data being stored in the database server. So there is no application without a database. You're sending the mails, receiving the mails, where this data is in the database server. When you order the food apps, you're doing a transaction, you're making the transaction, where that information will be stored in the database server. So both the database, both the servers are connected with the database. Both the servers are connected with the storage box. This storage box contains database. We install the database here. Just a small, simple example for what is application, what is the load balancer, what is the database. In the real time, you see like Cognizant, IBM, Wipro, there are more than 10,000 servers throughout the world. There are more than 5,000 servers only in India. In Bangalore and Chennai, in Hyderabad, there are more than 5,000 servers. Throughout the world, there are more than 10,000 servers. So imagine that how much infrastructure they are maintaining if it is physical data center. So to access this application, we need a switches and routers. What is switch? What is router? What are these physical devices? How it works? We'll discuss later when we start AWS. All this storage, what are the types of storages? How it works? What is this load balancer? How it works? What is switch? What is router? What are the differences? Everything we'll discuss. Start from the scratch once we start AWS. So this is how the application will work in the real time. So we need a load balancer. This load balancer will distribute the load. So here we have only 2 physical servers. Real time there are more than 10, more than 30 servers running and running multiple applications. So this is the concept of how this physical data center will work. Now, what are the drawbacks of on-premises data center? What are the drawbacks, disadvantages of on-premises data center? On-premises data center. IBM, they have their own data center. Wipro, they have like every MNC company, they have their own data center. It is a on-premise data center means what? We can see the physical location. Open the Google map. There we can see where the IBM data center is in Hyderabad. Where Wipro data center Hyderabad. We can find out in the Google map. That is called physical location. We are able to see that. You can go there. You can able to see that. If you are a infrastructure administrator, if you are infrastructure administrator, these people are working in the physical location of data center 24/7. Their salaries are high salaries. They are going to pay 30-40 lakhs for these guys who are working on physical data center. For working on physical data center, their job is the infrastructure administrator. Their job is 24/7. 24/7. The server should be keep on. The server should be keep on up and running 24/7. Make sure that the application is keep on up and running. When this application will keep on up and running 24/7, when my physical server is up and running, there should not be any issue in the network. There should not be any issue in the storage. There should not be any issue in the operating system services. So as a Linux administrator job, as a cloud admin, Linux admin, cloud admin, you're nowhere related to the physical server. You're nowhere related to the physical infrastructure. We are only related to the services. We are only related to the services or application. Your job is the services application. There should not be any downtime. The services application, there should not be any downtime. That is job of your cloud admin. The job of Linux admin. But there are separate engineers who are working in the physical data center. Their job is make sure that this hardware is available. The hard disk, storages, switches, routers, there should not be any downtime for this hardware. The hardware should be make sure that the hardware should be available 24/7. The server should be kept on up and running for 24/7. So there is a separate admin team for this who are working in the data center. So they have a physical location. These people are working in the physical data center. But as a cloud admin, I'm nowhere concerned with where this data center is. Tomorrow is joined as a cloud admin. There are two types of cloud. There are two types of cloud, private cloud and public cloud. We'll discuss later what is private and public. Private cloud are maintained by their own organization. IBM, they have their own private cloud. Wipro, they have their own private cloud. Every company, they're maintaining their own cloud. Every company, they're maintaining their own cloud, which is called private, maintained by their own organization. So, but public clouds are third party like AWS, Amazon, third party, Azure, GCP, all these are third party, which are called public cloud. First of all, what do you mean by cloud? What is the definition of the cloud? Why always say cloud? What is the definition of the cloud? Accessing the resources over the internet. A simple definition of the cloud. Accessing the resources over the internet. Gmail.com. You are able to access mails from Gmail. Do you know where this Gmail.com web server? Gmail.com is a web server. Gmail.com is a application server. Gmail.com is a mail server. When you type gmail.com, we are getting some application, static web application. Initially, we'll see the static web application. After that, we are giving the credentials, login name and password. That is called dynamic web application. After that, we are able to send and receive the mails. That means it's a mail server. It's a mail server. Because of the mail server, we are send and receive the mails. We are able to access gmail.com with a host name, not with IP address. Are you going to give the IP address of gmail.com in the browser? What is the IP address of gmail.com? 202.141.21.4. This is the IP address of gmail.com. Are you going to give the IP address of gmail.com in the browser? I can't able to understand this IP. I can't remember this IP address. What I'm giving, I'm just giving www.gmail.com. But system cannot understand System cannot understand what is this. System understand only IP address. So there is a DNS server already configured, domain naming service. The job of DNS is host name to IP address. When I give the host name, it is converted into IP address. So gmail.com is also a DNS server. Gmail.com is an application server. Gmail.com is a web server. Gmail.com is a mail server. But I don't know where this server is. I don't require the physical location of the server. I just need internet connection. Without knowing the physical location of where gmail.com, where Facebook is, they are able to access through internet. That is called as a cloud. That is called as a cloud. Even if you take docs.google.com. What is docs.google.com? It's a Google Drive. It's a storage. Google Drive, nothing but a storage. Where is Google Drive? Where the storage is? I don't know where the storage is. I'm able to access through internet. Any kind of resources we are able to access through internet, that is called as a cloud. Cloud means what? We don't know the exact location of the data center. We don't know the exact location of the data center. We can't see that in the Google map. It is not visible to you. So any kind of resources if we are able to access through internet, that is called a cloud. So private cloud means the companies are maintaining their own cloud services. That is called private cloud. So this is the visible for us. We are able to see that. We can go there. We can see that, but we can't able to see the public cloud. So now coming to the drawbacks of our on-premises data center, physical data center. One is called CapEx. What is CapEx stands? Capital expenditure. Capital expenditure. Second one is time consuming. Third one is maintenance. The drawbacks of on-premises data center, physical data center. One is CapEx, capital expenditure, time consuming, and maintenance. These are the major disadvantages of physical data center. So I have a physical data center, I have the server, I have one physical server, running some application. All of sudden, my application is terminated. All of sudden, my application is terminated. That is because of lack of memory. That is because of lack of memory or lack of CPU. Either RAM, lack of memory, or lack of CPU. If the application running out of memory, when the application running out of memory, out of CPU, the meaning of out of memory, out of CPU means there's no free space in the RAM. My CPU is fully utilized, 100% utilized. My CPU is 100% utilized. Then the process get killed. The application, the process that get killed. Hello. So రాగానే చెప్తుంది ఏ టైంకి వచ్చింది 21.
రేపు జాయిన్ చెప్పి కనట్లేదు సార్.
So my process get killed or application get killed. That is because of out of memory, because of out of CPU utilization. Out of CPU utilization. So what is the admin job now? If it is physical data center, I have to purchase the memory, RAM, add the memory to the server. To add the memory to the server, I need to shut down the server. You want to add a processor, CPU, you have to shut down the server. If I shut down my server, downtime to my application, downtime to my end user, they can't access my application. When we shut down the server, add the memory and start the server, it may take 4 hours, 5 hours. It may take 4 to 5 hours. That is called downtime. So if it is, this is the problem with the physical data center. If you go for cloud data center, AWS cloud, Azure cloud, if it is a cloud data center, based on the load, I can scale my application. I can scale my application as well as infrastructure. No downtime if it is a cloud. I can scale my application means what? If this server is down because of out of memory, your application automatically switch out to the other server. We discussed earlier the load balancer. When I configure load balancer, the application running both the servers, I configure load balancer due to lack of memory, lack of processor. If this application killed here, it automatically switch to the other server. This is called scaling the application. This is called scaling the application. This we can achieve. This we can achieve in the cloud. Not possible if it is physical data center. Physical data center is possible, but there is a downtime. There is a downtime, but no downtime if I go for the cloud. Based on the load, I can scale my application as well as infrastructure. When both the servers are, when huge network traffic on both the servers. There's a huge network traffic on both the servers. For example, you take Flipkart. Flipkart, they're going to announce the sale every year. Every year they're going to announce the sale, saying that March 31st, March 31st, or November 31st, they're going to announce the sale, saying that November 31st, the TV, 1 lakh TV, they're giving for 50,000. 50%, 50% discount on the TV, or 70% discount on the TV. They announce the sale November 31st. If regular traffic is like, for example, 10,000 people are accessing this application regularly, in the sale date, November 31st, it might be more than 20,000 people are accessing my application because I announced the sale. So in that case, my server is not capable to handle 20,000 applications. My server configuration is only can handle only 10,000 applications, 10,000 requests. Suppose I start a business, a small business. For that, I need one physical server. Initially, I have only 1,000 customers. After 3 months, my customers are increased. When my customers are increased, this server can't handle more than this 1,000. Then I'm going to purchase 2 more physical servers because my customers are increased. The same configuration, I purchased 2 physical servers. Now my customers are 5,000. I started with 1,000. Now my customers are 5,000. So 5,000 customers I can, with 3 physical servers I can manage. But after 3 months, my customers are increased to 10,000. I have to add another 3 physical servers. Add another 3 physical servers. And here we have a load balancer. Here I configure load balancer. This load balancer will distribute the load. This load balancer distribute the load. And all these customers are actioning application with the help of this load balancer. So whenever the traffic comes to the load balancer, the traffic is first sent to this server. If this server reaches number of requests, then send to this server. If it reaches number of requests, then send to this server. That is the job of the load balancer. So when my customers are keep on increasing, I'm going to add more number of servers so that my application is available 24/7 to the customer. This is about the physical data center. When more customers are added, you have to add more infrastructure. But after 1 year, other competitor develop the same application with new features, advanced features. My customers are switching from my application to other application. Means my customers are slowly reducing. In that case, what I have to do? I have to remove all these servers one by one. There is no that much network traffic because my customers are reducing. I have to remove these servers one by one. What's the problem here? Capital expenditure. I have invested 30 lakhs, 40 lakhs for every server. So these servers are some servers are 1 year also. There are some servers more than 1 year. So these servers are 40, 50 lakhs each server cost. In 2013, I purchased 2 servers. Each server cost 3 lakhs. Each server cost 3 lakhs. 64 GB RAM, 2 processors. Now those 2 physical servers are not working. That is my capital expenditure. I invested 6 lakhs, wastage of money. So here also, when the customers are reducing, I have to remove the servers from the network. I already invested 30, 40 lakhs on this. That is the problem with the capital expenditure. If I go for a cloud, whenever the traffic increase, it automatically launch on the server. When the traffic go on increasing, when the customers are increasing, means traffic is increasing, it automatically launch on the server. But there is a condition here. The condition is when RAM utilization, more than 70%, this is the first condition. Another condition, my CPU utilization more than 80%. Any one of this, the condition any one of this, either this or this. When the RAM utilization 70 and CPU utilization more than 80%, it automatically launch on the physical server. If this also reaches more than 70-80%, launch on the physical server. If it also reaches more than 70-80%, launch on the server. When these servers are going to terminate, we have to write another condition. When my RAM utilization less than 80%, or less than 70%, terminate this instance. In AWS, we call it the instance. In our data center, we call it the physical server. Here we call it physical server. Here we call it as an instance. Instance, nothing but a server. So my instance should be terminated when the RAM utilization less than 70%, or RAM utilization less than 80%. This should be terminated automatically. Here I'm not going to purchase these physical servers. I'm not going to spend any amount, I'm not going to purchase this physical server. There is no capital investment here. There is no capital investment here. For example, if my server I utilize it for, if this server I utilize it for 1 day, I'm going to pay only for 1 day. I'm not going to pay for whole month or the entire year. I'm going to pay only for 1 day. If my server is running only for 3 hours or 1 hour, I'm going to pay the amount only for 1 hour. It is not possible physical data center. We have to purchase this, which costs 30-40 lakhs. It is not required here. So whenever that is called scaling, application scaling. This is called auto scaling. Auto scaling means what? Whenever the application, whenever the CPU utilization, memory utilization more, automatically launch another instance. When the CPU utilization, memory utilization is less than the 70-80%, what is the condition we mentioned here? It automatically terminates. So one of the advantages of AWS is no capital expenditure. Today, I want to start a business. I got some idea to start one business, one application. To start that application, I need a physical server. I need a physical server. At least I have to spend 2 to 3 lakhs. But if you go for a cloud, I can take this server for a free of cost for 1 year. I can take the server for 1 year free of cost. We have a free tier. Free tier means the server is available for 1 year free. If you go for this physical data center, to start this server, to start the data center with 10 servers or 20 servers, I need a premises. I have to take the office. If I take the same infrastructure I'm taking from the cloud, the same infrastructure I'm taking from the cloud, I don't need to take any office. I can start my business from my home. What I require, I just need a internet. I just need internet. So these are the servers in AWS. One server configured for my website. This is a Terraform. Terraform is one of the AWS service. SonarQube is one of the DevOps service. So this Terraform service required, minimum 8 GB RAM. Minimum 8 GB RAM. If your laptop doesn't have 8 GB, only 4 GB, no need to purchase 8 GB RAM. You take this server from the AWS cloud. So no capital expenditure is required. When you create the account is free of cost for 1 year. So all the practicals we can do at the AWS. You want to start this physical data center. You want to start this physical data center with more number of servers, infrastructure. It may take 6 months to 1 year. You want to start the business cloud data center. Within 1 day, I can start. So if it is a physical data center, we have CapEx, capital expenditure. If it is a cloud, no CapEx, no capital expenditure. I can take this server for hourly based. I can take this server for monthly based. I can take this server for yearly based. So one advantage of AWS, we have a pay as you go model. Pay as you go model. Pay as you go model. What is the meaning of pay as you go model? What are the services? What are the services we are consuming? If I am consuming the services for 1 hour, I am paying only for 1 hour. That is called pay as you go model. In mobile, we have prepaid, postpaid. We are paying we are paying the amount to the service providers. how much you are consuming, how much you are using. That is called pay as you go mode. This is one of the advantage of AWS. Next, time consuming. Time consuming. If it is on-premises data center, assume that this is on-premises data center. If it is on-premises data center, I will not be able to scale my infrastructure as quickly as possible. I can't scale my infrastructure. I have to purchase this server from IBM, from Wipro, from Dell. If you order the server today, they may take 1 week also. They may take 1 week or more than 1 week to deliver the server. I can't scale my infrastructure as quickly as fast. Whereas if it is cloud, within a second, it will launch another instance. When this RAM utilization, CPU utilization more than this, immediately launch another instance. If it also reaches more than 70%, immediately launch another instance. So here, scaling infrastructure is very quickly and fast. So this is about CapEx, capital expenditure, and time consuming. So tomorrow class, we'll discuss about maintenance. Same time. So any questions? So till Friday, we have a theoretical part. Friday, I'll show you how to create an account in AWS so that we can see the practicals from Monday onwards. Any questions, guys?